My name is Mike Chamberlain. This video is a presentation of my research into the manufacture of cross-laminated timber in the United States, as well as my resulting recommendations. The development of cross-laminated timber, or CLT, in Austria and Germany in the 1990s was primarily a result of a desire within the sawmill industry to find a higher value use for the sideboards of that time. The inclusion of code language in the 2015 International Building Code provides standardization and reliability, both for manufacture and for use of CLT, to the construction industry in the United States. When compared to reinforced concrete or structural steel, CLT displays performance that is either comparable or superior in most categories. Despite the fact that CLT would provide solid performance while delivering huge benefits in terms of sustainable construction and a reduction of environmental impact, it is simply not competitive in the United States except for a few very limited regions. Long-distance shipping inflates the cost of using CLT too much to keep it marketable in the United States. Further, with only 3 manufacturers in North America, the available supply is relatively low. Promoting manufacture in the U.S. would address both of these concerns. Cross-laminated timber is most commonly manufactured using 2x lumber in panels a minimum of 3 layers thick. It provides good thermal insulation at an R value of 1.25 per inch of panel thickness, the smallest panels achieving an R value of 5, and the largest panels available today, which are most commonly 19 inches thick, provide a solid R value of 23.75. The fire protection performance of CLT is heavily dependent on the adhesive used in manufacture. CLT manufactured to code burns like timber, slowly. Furthermore, CLT panels are solid, giving fire nowhere to spread unseen. CLT blocks sound very well, far more than light wood or steel framing, and without the addition of fiberglass or composite fill materials. As a combination of the fundamental strengths of wood and the cross-lamination process itself, finished CLT has a high strength-to-weight ratio. The sturdiness and performance of CLT panels are comparable with reinforced concrete, with a 75% reduction in weight. The seismic performance of CLT is excellent. With well-designed and properly employed mechanical fasteners, CLT construction contributes to decreased loss of life in earthquakes. Additionally, permanent structural deformations are less likely, leading to a decreased loss of infrastructure. CLT panels are delivered to the construction site ready to install, with most or sometimes all openings already completed. The relatively lightweight panels do not require large cranes to lift and install quickly and with smaller than average crew sizes. This table shows a comparison of a hotel built using CLT for all structural elements as well as all internal partitions. You will see an improvement of 37% in structural duration, a reduction of 43% in average number of employees, and an increase of 75% in daily structural production. The other hotels used in this comparison had a variety of building systems, including light wood framing, CMU masonry, and steel. As a note, in the figure shown, we are looking at more than half of the entire construction crew for this project. When comparing the cost of construction using CLT with more traditional materials such as concrete, steel, or light wood, it is beneficial to consider the height of the structure. Due to the high weight of the materials, construction using concrete or steel grows more expensive as the structure height increases. Both CLT and light wood framing are much lighter. which translates to more stable pricing. As a structure grows beyond the limit of light wood and beyond the heights in which concrete and steel are less expensive, CLT becomes the most cost-effective alternative. When discussing sustainability, please consider that CLT effectively competes with both concrete and steel, which are unsustainable materials. CLT, when utilized, provides superb reductions to the environmental impact of construction products. Further, it is highly recyclable. Panels can and will absolutely be reused in multiple buildings. And when not reused in some fashion, CLT panels can be ground into wood pellets and used as a fuel source. Because of this, CLT sequesters large volumes of carbon for long periods of time. U.S. Green Building Council Leadership in Energy and Environmental Design, or LEED, credits that are available for buildings incorporating CLT include the following: construction waste management, due to the fact that CLT panels are highly prefabricated; materials reuse, thanks to the ease of deconstruction and reuse of CLT; and certified wood. This category obviously depends on the sourcing of the wood used to manufacture the panels. For example, mountain pine beetle killed wood can be used to make beautiful, even artistic CLT, thanks to a blue tint left by the beetles. The beetles typically only attack mature trees, however, which prevents certification by the Forest Stewardship Council. The final category, regional materials, is available for materials manufactured or sourced within 500 miles of the construction site. The figure you see here shows 3 circles. Each of these circles is a very close representation of a 500-mile radius around an existing CLT manufacturing facility. Much of the U.S. and North America is far, far outside the circles. I had the opportunity to visit the ribbon cutting for the first all-CLT hotel in the United States, Candlewood Suites on Redstone Arsenal in Alabama. I spoke with members of every aspect of the project. Lend-Lease owns the hotel and also operated as the general contractor, with investment from the U.S. Army and to U.S. Army standards. The CLT used in construction was manufactured by Nordic Engineered Wood Products in Montreal, Quebec. The primary structural engineer was Doug Steimel of Schaefer Incorporated, with a great deal of input and assistance from the manufacturer Nordic. As previously discussed, this project was completed quickly and with a reduction in necessary crew size. All elements of the building, in fact, were met with acclaim from every involved entity except for the cost. This project was bold, risky and experimental use of a product without much precedent in the United States. Interestingly, 6 other hotels have been built quite recently by the same cooperative group, all on military installations, and all to similar design standards. This allowed for a useful cost comparison. Though I was not provided with specific material cost data, as such data was considered sensitive, I was able to review a quantitative cost comparison prepared for the Office of the Deputy Assistant Secretary of the Army for Installations, Housing, and Partnerships. The CLT construction costs were an increase of 22% over the next most expensive analogous hotel, and 39% higher than the average of the other 6 hotels. After reviewing the construction and design decisions, I believe I have determined the primary causes for the cost increase. First, CLT was substituted not only for concrete and steel structural elements, but also for all interior partition walls, which would normally be constructed of lightwood framing. The thick CLT caused a 14% increase in overall square footage, with resulting increases in cost for every aspect of construction from the foundation to finishing. Furthermore, CLT is simply more expensive than light wood framing. Second, and finally, 1,200 large, sometimes very large, CLT panels had to be shipped 1,950 miles from Montreal to Redstone Arsenal. In effect, a significant time savings and an excellent reduction of environmental impact was purchased for a significant financial cost. In conclusion, CLT is an excellent alternative to non-wood, mineral-based building materials. Substitution of CLT greatly reduces environmental impact while providing superb performance. When substituted for concrete or steel, CLT can compete and win in terms of cost. A growth of CLT manufacture in the United States would benefit the construction industry. Competition, innovation, and reduced shipping would reduce costs, promoting the increased adoption of an interesting and sustainable material. The federal government, acting in its role as the shepherd of our natural resources and our economy, needs to take a leadership role in the adoption of cross-laminated timber. This should begin with the creation of a market in federal construction projects, such as Department of Veterans Affairs clinics, Department of Education schools, and Department of Defense housing. Monetarily incentivizing the manufacture of CLT in the U.S. and allowing sustainable harvest of wood on federal land would encourage and speed the growth and spread of the CLT manufacturing industry. Further, incentivizing use by states, state institutions, and private owners would provide a long-term market. A federally hosted forum with a focus on CLT would be an excellent starting point for this process. Your feedback is very welcome. Please direct any questions and comments to the email shown. Thank you, and have a great day.